Let's talk about a germ that is so common, it's pretty much a childhood rite of passage. But, behind its very familiar name, there's a pretty wild story about a surprisingly dangerous and adaptable superbug. This is really the story of a wolf in sheep's clothing. I mean, think back. You remember it, right? That raw, scratchy sore throat, the fever, that trip to the doctor for the swab. Yeah. For millions of us, that's our entire experience with strep. It's annoying, it's definitely painful, but, a round of antibiotics, and it's over. But what if I told you that simple throat infection was just the tiniest tip of the iceberg? That the exact same germ could lead to flesh-eating disease, permanent heart damage, and, get this, is responsible for 500,000 deaths every single year. Yeah, this is the story of a superbug that's been hiding in plain sight this whole time. Okay, so the culprit actually has a name. Group A Streptococcus, or GAS for short. You can really think of it as a human specialist. I mean, it has evolved over thousands of years to do one thing incredibly well: infect us. It only lives and spreads among people, and it has developed a shocking number of ways to do its job. And that's because gas is not a one-trick pony. Not at all. It causes a whole spectrum of illnesses, and they range from the totally mundane to the truly terrifying. Just look at the sheer range here. On one end, you've got pharyngitis. That's just the scientific name for strep throat, which causes nearly 300 million cases a year in kids alone. Then you have scarlet fever, a disease we all kind of thought was history, but believe it or not, it's making a comeback. And then at the far end of the spectrum, you get the really severe stuff: necrotizing fasciitis, the so-called flesh-eating disease, and rheumatic heart disease, where the body's own attempt to fight strep ends up attacking and permanently damaging the heart. And this is the number that just stops you in your tracks. 500,000 deaths every single year. That puts Group A strep in the same league as some of the world's most notorious infectious diseases. It is so much more than just a sore throat.
So, how does it do all this? I mean, how can one single bacterium cause so much chaos? Well, it's actually pretty straightforward. Group A strep has an entire arsenal of secret weapons, a really sophisticated toolkit for evading and manipulating our immune systems. Seriously, think of this bacterium like a master spy with a three-step plan. First, it has to disguise itself. It actually wears an invisibility cloak made of a substance our body doesn't recognize as foreign. Then it infiltrates, using toxins to literally punch holes in our cells and break down barriers. And finally, it disables our defenses by cutting the communication lines of our immune system and dissolving the traps our own cells set for it. It makes a clean getaway. And its toolkit does not stop there. It has this toxin called SWIB-B that acts like a Swiss Army knife. It breaks down our tissues and completely confuses our immune signals. It unleashes things called super antigens, which basically trick our immune system into a full-blown panic, creating this massive self-destructive overreaction, a cytokine storm. It can even produce an enzyme that dissolves blood clots, just clearing a path for it to spread all through the body. It's incredible. Now, for decades, we've had a pretty reliable way to fight back against this whole arsenal: antibiotics. But there's a big problem. This superbug is learning our playbook, and our best weapons, well, they're starting to fail. Okay, take a look at this chart. This is what's happening in the US. Macrolides, things like erythromycin, are the backup antibiotics we use for people who are allergic to penicillin. Now just look at this trend. In less than a decade, resistance in these dangerous gas infections has more than doubled. That means nearly a quarter of these infections are now resistant to our main backup plan. But this is the development that has scientists really, truly worried. Penicillin has always been the gold standard, right? The one thing we could always count on to kill Group A strep. Well, for the first time ever, researchers are finding strains with mutations that make them less susceptible. Now, it's not full-blown resistance yet, but it's the first step on a very, very dangerous path. So not only is the bacteria getting tougher, it's also getting meaner. New genetic versions, or clones, are popping up. One in particular, called M1UK, is driving these huge surges in scarlet fever and invasive disease. It's more aggressive and it spreads more easily. So with our treatments under threat, the ultimate goal has to be prevention. The holy grail in the fight against Group A strep is a vaccine, but it's a race science has been running for over 100 years. Which, of course, begs the question, if this bug is so common and so dangerous, why on earth don't we have a vaccine for it yet?
Well, as it turns out, this very clever bacterium presents some pretty unique challenges. It really comes down to three huge hurdles. First, there's just massive diversity. The part of the bacteria our immune system grabs onto, this thing called its M protein, it comes in over 220 different types. So a vaccine has to work against as many of those as possible. Second is the autoimmune risk. Remember how strep can cause rheumatic heart disease by tricking our immune system? Well, scientists worry a vaccine could accidentally trigger that same friendly fire. And finally, you need global coverage. The strep in one part of the world can be different from another, so a vaccine has to be truly universal.
So to get over these challenges, scientists are basically trying two main things. One strategy is to target the head, that part that's always changing, the M protein. This means you have to make one big vaccine cocktail with pieces from dozens of different strep types. The other strategy is to target the body, to find a part of the bacteria that never changes and aim for a single universal vaccine that could defeat all of them at once.
But after decades of pretty slow progress, the tide might finally be turning. There's this new sense of urgency, and now the World Health Organization has officially declared a GIS vaccine a global priority. And that is reinvigorating research and a whole lot of investment. So here we are at a really critical moment. We have this super common germ with a deadly dark side. It's an ancient enemy that's evolving faster than ever, learning to evade our best medicines. The stakes could not be clearer. The question is, after a century-long race, can science finally deliver the ultimate weapon to stop it for good?